Hey everyone, how you guys doing? Hope you're doing well. So, what we're gonna do today is we're gonna continue our SFML series. We're gonna continue with our RPG game, and yeah. So let's continue that. So Google SFML, and I'm gonna go to the Learn section and the Tutorial section. And we'll start with creating a window. So open and manage window in SFML. So this only creates a window, doesn't necessarily allow graphics. So we're gonna go to draw 2D stuff. All right, perfect. So this section essentially. All right, so we draw 2D stuff. What I'm gonna do is put this code side by side with my project. Like, whoops, wrong window. All right, side by side like that. And I'm gonna start typing up code and kind of explaining what's going on. Now, like I mentioned before, SFML is a simple fast media library, allows us to render things on screen. And essentially, it's a framework that helps us make the game, right? And so to get started, the first thing we need to do is create a window, right? So what I'm gonna do is do hash include SFML slash graphics.hpp, right? And so just to remind you again, this is just the preprocessor. And what this line does, it just copies all the content from this graphics.hpp file into our main.cpp file, right? All right, so in our main function, we're gonna start rendering a window. Now, SF : this is your SF namespace. And we talked about namespaces before and what they do, right? So that's your SF namespace, and inside it there is a render window. Render window is a class which allows us to just create a window to draw things on. So what I'm going to do, I'm going to create an object of type window inside, right? So SF window is the data type, it's the custom class data type, and the window is the actual object or the variable. All right. So next, window, while it is an object, whenever we do open the brackets like that, we're calling the constructor of render window. And I haven't talked about constructors at all. All I can tell you for now, just to keep it brief, a constructor essentially is a function. So this render window class has a function that is called when you create the objects for the first time. So when I create the window object, like I'm doing right here, it calls a constructor function, or it calls a function that initializes the window, that sets some variables up to default values. So I'm creating my window. I'll explain constructors in a lot more detail later on, but essentially all you need to know is the constructor is just a function that's created, or it's a function that gets called when you create the window object. Right. So inside this window, it's going to take 2 arguments. And the first argument is the video mode. So SF video mode. And the video mode, but basically, again, it's a class. And you can see there are, it takes, if you look here, it takes the width and the height of the window. So I'm going to create 800 by 600 window. And the next argument in this function is the window title. So my window title is going to be RPG game. Right? By making this a little bit bigger, smaller, see all in one line. All right. So real quick, just to explain this line one more time. SF is our namespace. Render window is a class. I am creating an object or a variable. We call it an object. I'm creating an object out of the render window, so I can use the render window. This object, when I create it, it has brackets, so it calls the constructor of the render window class. This constructor is basically just a function that takes two arguments. The first argument is video mode. The second argument is the window title. This constructor is a function that's going to run when you create this game object, or sorry, not game object, when you create this object, and it's going to initialize the window, essentially. Now, SF video mode is a class, again, that takes two arguments. The first argument is the width and the height of the window. First and second arguments, width and height. And then the second argument for the window is the title. All right, so now that we have all that set up, if I press play, I should be able to see a window that's 800 by 600 with the title RPG game, which I see. So I don't know if you've picked that up, because when that happened, the window started and closed real quickly. But I did see a window, right? But it started and closed. And the reason for that is we started our program, we created the window, and then we were done creating the window. So the program was like, okay, cool, nice job. And then it closed, right? So we want to keep that window running. To do that, we're going to create something called a loop. And I haven't talked about loops before. But a loop is essentially something that happens over and over and over and over. In all applications, there is a loop that keeps the application running, right? Because if you execute some code and you finish, the application is going to exit and it's going to be done. We want to keep that application running. So we put it in a loop, right? In our case, in game development, this loop is called the game loop. And the game loop essentially just updates the game and draws things on the screen. To demonstrate that a little bit better, if I go here, let me zoom out. Here. Demonstrate this a little bit better. This is our application over here. Right, this is our game. If we just tell it to draw the window, then it's going to draw the window and then it's going to exit and we're done here, right? What we want to do is we want to draw the window, or we want to create the window, and then there's going to be a loop here. And what we do is we call this a while loop. While loop. This while loop is our game loop. So what is our game loop? What does it contain? Well, our game loop contains two very important things: update and draw. Those two functions are very, very important. So basically what happens, we create the window, and then we put our application in a loop. This loop will update everything inside the game. So for example, if you have a character, it's going to update that character. If you have an enemy, it's going to update the enemy. Updating just basically means, in the update function, what we basically do is it's going to check if you press a key on your keyboard. For example, a W key. If I press the W key, I'll make my character move forward. So that's handled in update. So any movement code, any animation code, anything that requires to be updated every single frame happens in update. Now, we haven't talked about frames a lot. We'll cover that in a second. That's essentially what update does. Draw, on the other hand, draws everything in the game. So your enemies, your players, your building, your environment, the trees, everything in the game happens in the draw function. And this entire thing is called a loop. it's called the game loop because it happens over and over and over. Now, let me talk about frames. If you're not familiar with frames, and it's possible for whatever reason you don't know what frames are, if you ever played a game, you might have seen a frame counter like 30 FPS or 60 FPS or whatever your frame counter is at the time, right? So what does FPS stands for? Well, FPS stands for frames per second. That means how many frames are we drawing on the screen per 1 second. Now, to demonstrate this a little bit better, if I go here and I open YouTube, I can type, right? And let's say I go to drawing frames. Flipbook drawing. There you go. Essentially, everything, all our media consumption, like film and games, everything is made of images, still images, right? These still images are drawn many, many times in one frame to give you the illusion of motion. So for example, you can see here that what he does is essentially he draws every single frame by frame or every single image, and he moves the images or he flips the images with his finger really quickly, and that will give you the illusion of motion. So you can see you have motion, which is super, super cool. And that's the concept in film and the concept in video games, right? Essentially, what we do in video games is we literally draw an image, and then when we're done, we draw another image, and then we're done, we draw another image, and so on and so forth. And we do that usually to have smooth motion and smooth gameplay. We do it 60 times in 1 second. So we're drawing 60 different images in 1 second. And those images, obviously, they're slightly different between each other. And that will give you the illusion of motion. And you can see it's being done here manually. That's what happens in film, and that's what happens in video games. Now, with film, we run at 24 frames per second. In games, we want to run as high as possible. So 30 frames is better than 24. 60 is way better than 30. 120 is way better than 60. 144 is better than 120. 240 is better than 144, and so on and so forth. The higher the number, the better and the smoother the motion is. And that's our job. Our job is to update every single frame, update the game, and draw everything in the game. So going back to this, our loop, a single iteration of my loop, is drawing one image or one frame. So in a loop, in my update function, I check for all key inputs. If the player has pressed the W key, the S key, anything on the keyboard. And we also check for mouse movement. So we basically check for all inputs in the update. We also check for animation, or we update the animation, or we update the UI, the user interface, or we update the AI, the enemy AI, or we do pathfinding. We find the shortest path between 2 points for our enemies. Whenever we need to update in our game, in that frame, we do it in this function. And then when we're done updating, we draw everything on the screen. And this happens every single time. For every single frame, we update and draw, update and draw, and so on and so forth. Now, whenever we're drawing stuff, when we draw stuff on the screen, what happens is when we start our drawing process, the first thing we do is we clear our screen. We make sure nothing is drawn on our screen. We clear our screen, and then we start drawing stuff. Like our character, we start with our character, and then we start with another character. Then maybe you start with the tree. That's not a tree. You start with a tree and maybe a house. I don't know why these guys are bigger than a house, but whatever. And here's your chimney. Classic house. Right? I'm a true artist, by the way. And we draw our clouds and we color everything up, right? So we drew this frame, and the next frame, we clear the screen again. We make sure there's nothing drawn on the screen, and we draw everything again. Maybe this time the player have moved a little bit to the right. So now he moved a little bit to the right. And this is my house. Beautiful house. Greatest house in the world. And apparently the tree also moved for whatever reason. But whatever, right? So the guy moved a little bit slightly to right. Distance here is a little bit closer. Right? And we do that every single frame. Now, when we do this, here's a potential issue. If we clear the screen every frame and draw things on the screen every single frame, the screen draws from top to bottom. So top to bottom. Right? So it draws every single pixel from top to bottom. If you don't know what a pixel, by the way, screen is made of pixels. Just in case for those people who don't know, the screen is made of pixels, right? Tiny little pixels, which have values that are called, they have, each single one of these pixels have RGBA values. Actually, let me do this properly. R, G, B, and A values. R stands for red, G stands for green, B stands for blue, alpha, and A stands for alpha. And alpha is your transparency. If you don't know what transparency are, we'll talk about it a little bit later. But essentially, every single pixel you see on the screen is made of these four colors, or actually 3 colors and an alpha or transparency. So if you have a big image, right, whatever image it is, that image is made up of pixels. So for example, we can say that this image is 800 by 600 pixels, right? So if let's grab a random image. Let's go here, google.com. Let's do pixel art. So let's take a 16 by 16 pixel art. Is this 16 by 16? I don't know. We'll see. Can I steal this for demonstration purposes, please? Thank you very much. I really appreciate it. Put it here. Go open Paint. Right? Everyone has Paint on their computer. I'm going to go to File, Open. I'm going to go to my desktop. The question is, which image was it? So we'll do extra large. There you go. All right. So this image currently, you can see at the bottom here, it's made of 1440 pixels by 960 pixels, meaning that the width of this entire image is 1440, and the height is 960. That's how many pixels are there. And if I zoom in and really zoom in, you can see that every square of this image, okay, well, this is a problem because this is not quite demonstrating my point. Is this 16 by 16 image? No, it is, well, good enough. Right? You can see this image, right? Every single square here is a pixel. And a pixel essentially is the smallest unit that you can measure on your screen. And every pixel can have the 3 colors and your alpha. So for example, in here, as you can see those on my screen, I have a large screen. So this is 1 pixel for that specific image. For this specific image, this image is 16 by 16 pixels. So every single square is a pixel. So I can put a pixel here if I want to. Now this is my pixel. I put a blue pixel or a purple pixel. I can put a yellow pixel, and so on and so forth. So every single one of these squares are 1 pixels. Is 1 pixel. Now, if I make this image much bigger on my screen, right? So for example, right now, this image is occupying a much bigger space on my screen. So that means that every single square is taking more than 1 pixel on my specific screen because it's so zoomed in. If I zoom it out, and I wanna try to, can I control Z? Can I save this or export it? Thank you. PNG, yes, thank you. Open the file. Thank you very much. Can I, right, we're going to the downloads folder. Open with Paint. All right, you can see how tiny this image is. That's because this is actually every single pixel on my screen, right? So if it's actually at 100 scale resolution, every single pixel is a single square. But if I zoom in a little bit more, right, that means that this image currently is occupying, every single square is occupying more pixels on my screen, right? But if it's 100% zoom, that's the normal resolution of the image, then that means every single pixel is taking every single pixel on my screen. I have more pixels on my screen, right? But in the context of this image specifically, every single square, no matter whether you zoom in or zoom out, every single square is a single pixel, right? And it has all 3 values and an alpha. I hope it didn't confuse you with the whole zooming thing. If I did, you can just ignore that part. And all I want you to know is that this image is 16 by 16 pixels. A pixel is just a square with 3 different colors, RGBA. So 3 colors and 1 alpha, an alpha channel. We'll talk about an alpha channel later, or what transparency is. And every single square is a pixel with these 3 colors, and this is a 16 by 16 pixel image. That's it. That's what a pixel is. That's all I want to mention about that topic. Right? So what we've done here, what we've said, what we've told SFML is that we want to create an 800 by 600 window. That means this window has 800 by 600 pixels. There's 800 pixels on the width and 600 pixels on the height. Right? And every one of these pixels has a color, which is RGB and the alpha channel. Now, going back to the drawing, I was mentioning that we draw from top to bottom. We draw every single pixel from the very top to the very bottom, right? And whenever we're drawing a new frame, we do that process from top to bottom. Now, here's the thing. If we just draw everything on the screen and show it to the player, there might be an issue when we start drawing the second frame. Because here's the thing. I'm gonna start drawing my frame. So I'm gonna draw my frame here. I'm drawing my frame, drawing everything, right? I'm drawing all the pixels, I'm drawing them. And then when I'm done drawing them, I'll have my image here. with the guys, right? Now the next frame needs to start rendering, right? I would like to start drawing the next frame. Now, I can't, if I start drawing the second frame, I'll draw it from the very top. I might have an issue that's called, where's the issue called? Not stuttering. Tearing. I might have tearing in my screen, which is an issue. So if I Google tearing, tearing is essentially the phenomenon of you starting to draw the second frame before the first frame ended, or while the first frame is still on the screen. So you can see that I started drawing the second part. If I get my epic pen, I'm starting to draw the second frame of my image before the first frame ended, or while the first frame is still there. And that is a problem, right? So this is my second frame over here. So this is second frame. This was the old first frame, right? And that's an issue which can be fixed by creating multiple buffers. Now, the question is, what's a buffer? Well, essentially, a buffer is just a box containing some data, right? You can think of it just as a box with some data in it. Now, in our case, this box or this data inside the box are just pixels. So I have just a bunch of pixels on my buffer. These pixels are colors, and these colors make up our image, right? So what I can do here, I can have my screen over here. So this is my screen, and this is I'm gonna call it the back buffer. What is the back buffer? Well, the back buffer is an area where we can draw stuff on it, just like our screen. So for example, I can draw something here on my screen, and I can draw something here on my screen, on my back buffer. Sorry, I can draw something on my back buffer, and I can draw something on my screen. Now, the disadvantage of drawing things on the screen immediately is that it will cause tearing to happen on your screen, like we saw here in the previous image before. Right? You can see there's tearing between the two images. So the solution to that is what we do is first we draw our image to a back buffer. The player doesn't see this. The player can only see our screen. Right? You, as a user, can only see your screen. But this, you cannot see. So I'm going to render everything to a back buffer. I'm going to draw my character, my lovely house, right, and my tree. I'm drawing all of this to a back buffer. And when I'm done drawing everything, I will take this, copy the data, and paste them here. When I do that, I basically eliminate or try, well, if I do that, I eliminate the problem of tearing, but that's not completely true because tearing can still happen even if you have a back buffer, right? There's still a possibility that you can have tearing, and I don't want to get into the whole complexity of that problem yet, right? But and you can reduce that problem by enabling something called triple buffering, right? Triple buffering. Right now, what we have is called double buffering. A double buffer basically means that we draw everything off screen. We don't draw it on the screen, we draw it off screen. And then when we're done, we copy that data to the screen, we erase everything in here, and we draw the next frame. So I draw my next frame on the buffer, all right? And then when this is done, I erase everything on my screen, and then I draw it. I copy it. I copy the data from here to here. And then while the data is being copied, or when the data was copied, I am now drawing the second buffer. or I'm drawing my second frame or third frame or fourth frame. Essentially, the idea is we don't want to draw directly on the screen. We want to draw it in an area where the player cannot see, which we call the back buffer. When we're done, we copy the back buffer to the screen, and then we start drawing the next frame. When we're done, we copy the data again to the screen, and we render our third frame, and so on and so forth. So all of our frames are rendered first on the back buffer, then they're copied onto the screen. And this will reduce the issue of tearing. It will not eliminate it completely, but it will reduce it. It'll be much, much, much better. And you can even reduce it even further by having triple buffering. So this idea here, the back buffer on the screen, is called double buffering. Triple buffering is when we have a third buffer. So third, back, or actually in this case it would be the second buffer. It has one buffer here, and the screen. So we draw something here, right? And then we copy it to the screen. And then something is being drawn over here, right? And then while stuff are being copied, when we're done, we start copying this. Then we go here, we render, we're drawing stuff, and then we even draw some more here stuff. And then when we're done copying, we move things on the screen. So this is just allows us to, if the GPU or the graphics card is moving way too fast, it has space to render things. The graphics card doesn't have to wait for it to render everything on the screen. We can draw something on the back buffer, and then we can copy to the screen later on, right? So that's the idea of double buffering and triple buffering, and the idea of tearing and reducing tearing, right? And what pixels are. So going back to our loop over here, we do this every frame. We have a loop called our main loop with our update function. Our update function goes and update our movement or animation, whatever we have to update. We update it, and then we start drawing stuff. We draw stuff on the back buffer. When we're done drawing stuff on the back buffer, we copy it to the screen so the user can see it. And then we erase the back buffer and we draw some more things. When we're done, we erase the screen, we copy the stuff to the screen, and then we erase the back buffer. We draw some more stuff. When we're done, we erase the screen and copy the things from the back buffer to the screen. When we're done, we erase the back buffer, and then we draw things on the back buffer, right? And then when we're done, we erase the screen, we copy things from the back buffer to the screen, and so on and so forth. You can see the process happening over and over and over and over, right? So, first, clear the back buffer, draw something on the back buffer. When you're done, clear the screen, copy it on the screen. When you're done, clear the buffer, draw something on the back buffer. When you're done, clear the screen, draw something on the screen, and so on and so forth. That's back buffering, right? That's it. That's the entire idea of a game loop and what happens every single frame of your game, right? Now, there are other reasons that screen tearing happens. For example, I would like to cover this, like really briefly. It has nothing to do with SFML or the topic at hand, but that's kind of cool, and I kind of want to talk about it. So remember how we said that this game loop, for example, it runs at 60 frames per second, meaning that we update and draw 60 times in 1 second. We go through this loop 60 times, over and over and over, right? If our computer was much faster, we can go through this loop maybe 120 times in 1 second, or 220 times, or 200 times per second, right? So the faster our computer is, the faster we go through this loop. The faster we update, the faster we draw stuff. Now the problem with this is that your computer display, has something called a refresh rate. Refresh rate. This refresh rate, if you have a normal monitor, usually is set to 60 Hertz. 60 Hertz basically means that the screen can only draw 60 images in 1 second. It's only fast enough to display something 60 times in 1 second, and it will not go above that. So this is my game, and let's say my game is running at 200 FPS. It's a super fast game. Even though the game is running at 200 FPS, you physically are only seeing 60 images of those 200 images in 1 second, right? And that contributes to the phenomenon of tearing. So if your game is running way, way higher than your refresh rate, then you have tearing issues because you're basically trying to draw things before they were done. It's so fast that you already started drawing the second frame before the first frame was done drawing, which is a problem. So to eliminate tearing altogether, we need the combination of back buffers, right? Having a back buffer and locking the frame rate to the refresh rate of the monitor. So if our monitor is running at 60 Hertz per second, then we want to lock our game to run at 60 frames per second or only display 60 frames per second. And that is what usually referred to VSync. VSync, if you turn it on, it's an option. If you turn it on, it will lock your game or your main loop speed to the speed of your refresh rate of your monitor. So if your monitor can only do 60, you can only do 60. If your monitor can only do 30 Hertz, you can only do 30 FPS. If you have a really expensive monitor and a gaming monitor and a fast monitor and you do 144 Hertz, you are able to render or see on the screen 144 FPS, right? And it's really important to distinguish the difference between FPS and Hertz, because just because your game is running at 2000 FPS, that doesn't mean you're actually seeing with your own eyes 2000 frames per second, because the monitor is only capable of drawing 144 of them. Physically, you can only see 144 in the real world, but the game is running at 2000. So that's why the higher the refresh rate of your monitor, the smoother the game experience is, and the smoother everything is, and the smoother your computer is. So I highly recommend, if you ever tried going above 60 Hertz, most monitors are 60 Hertz. I highly recommend trying or getting a monitor that's more than that, maybe 120 Hertz or 144 Hertz. That is life-changing. The difference between 60 and 120 and 144 is massive. It's like visiting a whole new world. It's super smooth. It's buttery smooth, right? So that's the difference between Hertz and FPS and what VSync does. You turn on VSync, it will lock your frame rate to your monitor refresh rate. If our refresh rate is 144, we only display 140, or our game only renders 144 frames per second, which eliminates tearing altogether with the help of back buffering. Right? Which is super cool. Now, why did I talk about this now? We're gonna need it later on. We're gonna, by default, I think by default, SFML turns on VSync by default. I could be wrong, but we'll check and make sure. Right? So, what we talked about is the main game loop. We talked about tearing, what VSync is, what back buffering is, what refresh rate is, what pixels are, and how many pixels your monitor has. By the way, if you want to know how many pixels your monitor has and what the refresh rate of your monitor, you can do that easily. If you right click on your desktop and go to display settings, you will see that in display setting, for example, for me, I have a 144, I have a 4K monitor, meaning that I have 3840 by 2160 pixels. So on the width, I have 3840 pixels wide, and high, I have 2160 pixels. If you multiply those two numbers, you find out the total amount of pixels I have on my screen. So 3840 by 2160, that'll be around the 8 million pixel range. Yeah, 8.2 million pixels I have on my screen. You could be running a 1920 by 1080p monitor. So 1920 by 1080. That's what the most common resolution is. And that's around 2 million pixels on your monitor. So 1920 by 1080. That means you have around, you have 2 million pixels on your monitor screen. Obviously, the higher the pixel count, the less jagged or jaggies you see on your screen, the less jagged your models are. So for example, especially in especially in 3D models. First, we're not gonna do 3D models, right? We're gonna do 2D game, so this won't affect us as much. So the higher your pixel count, the less you have of this a staircase effect. We call this a staircase effect because it's not smooth. Pixels are inherently square, so you can't have. It's hard to draw a circle, right, with a square. So what we do is we have two methods to fix that. We either add anti-aliasing, which anti-aliasing basically smooth out the edges. Without anti-aliasing, you can see how sharp the edge is. With anti-aliasing, the edge is much sharper. And so the higher your pixel count on your monitor, the less reliant you are on anti-aliasing, right? The less you need AA. We call it AA, right? Because you have so many pixels on your screen, and they're so very tiny that you won't notice them anymore, right? So on a 4K monitor, you still notice them a little bit, a very little. On an 8K monitor, even less, even they're gone, completely gone. On a 16 monitor, a 16K monitor, it's ridiculous. Right? So this is another example. If I'm drawing a line, you can see how jagged that line is. This is without anti-aliasing. This is with aliasing. Now each one of these squares are pixels, and if you zoom out, and if you have a lot of pixels, then you will not see this jagged line. Right? So if you want to see how many pixels your monitor has, you can just right click on your desktop, go to display settings, and you can see your resolution. If you want to check out your refresh rate, you can go to the graphics section. Sorry, not graphics. You go to the advanced display section, and you can see that my monitor is running at 60 hertz per second. Sadly, I don't have a 144 hertz monitor, but it's hard enough to drive a 4K monitor at 60 rather than 4K at 144. Right? So that's just something to keep in mind if you want to check out your screen resolution, refresh rate, and all that. All right, cool. So now that is out of the way, kind of explained that. Going back to SFML, closing off this. Right? You can see here that I'm creating a window, right? So that's where we left off. I'm creating a window, and what I would like to do is I would like to be able to create my game loop. My game loop, I can create it by making a while loop. And a while loop basically is just the word while and two brackets here. Now those two brackets, before I mentioned that usually brackets are for functions. This is not a function. A while loop can have brackets. So, sorry. So a while loop takes an input here, and this input is my condition. So for example, while loop looks like this. So this loop, code here, this loop will run for as long as our condition as sorry, as long our condition here is true, right? So as long as our condition here is true, the loop is gonna run. In our case, the condition would be while window dot is open. So let's look at that for a second. Now we know that window is an object, right? It's the object we created up here. This is our object. And this window object has a function called isOpen. IsOpen is a function that returns a boolean. And this boolean, you can see here, returns true if the window is open, false if the window has been closed. So basically here, what I'm saying is, while the window is open, execute code. Until we close the window, we don't exit this code. So we're gonna be stuck in these lines from line 8 to line 12 to line 11. From line 8 to line 11, we're gonna keep executing our code over and over and over until our loop is done. When our loop closes, or when our window is closed, we exit the loop and then we return 0 and our application closes. But before we close the window, we're stuck in here. And what we're doing is we're updating the screen and we're drawing onto the screen. And this is our main game loop. Main game loop. So now if I press play, you will see that the window is going to appear and it's not going to disappear. This is my window. I can't move my window. I can't interact with my window at all, but that is completely fine. Yeah, so this is my game window. It's 800 by 600 and it's running forever because we're stuck in this loop forever. Now, if I want to close my window, because right now I can't close my window at all. The way I can close it is by closing the terminal or our command line. If I close my command line, the window will close or application will close. So if I press play again, you can see I can't interact with the window at all. I can't even close it. I'm trying to close it and I can't. So if I want to close it, I just close the terminal over here. Right? So why can't we interact with the window? Well, we'll talk about that in a second. Again, real quick, this is our main game loop. A loop that continues on happening over and over and over. We're stuck between line 9 and line 10. This is the scope of my loop. And basically it's saying, hey, this is the condition. As long as this condition is true, the loop is running. When the condition becomes false, we're done. All right, cool. So why can't we interact with the window? What is going on? Well, here's the thing. In SFML, after we create our while loop, we have to create a second loop inside it. And this second loop is called the event loop. The event loop is a loop that checks for events from the window system. What are events? Well, when you click with your mouse button, that's an event. When you click on your keyboard, that's an event. When you want to try to move the window, right? If I try to move the window, that's an event. When I minimize the window, that's an event. Maximize the window, that's an event. Close the window, that's an event. If I press anything on my keyboard or my mouse or I move my mouse, all of these are events. So Windows, the operating system Windows, has an event loop. A loop, right? when the operating system Windows has events, and what we need to do is go through this, go through all these events and check if there's an event that occurred. So you can think of the event loop as this. So think of it as a queue, right? The operating system is here and your game is over here. If I move the window, for example, or I close the window, let's say I close the window. If I close the window, the operating system will add an event to this queue or list, right? It's usually a queue, right? Imagine you're, I don't know, you're at the ATM, right? You're at the ATM over here at a bank, and there's a queue of people that are trying to get money from the ATM, right? So essentially, what you're trying to do is, essentially that's a queue, right? So whenever you close the window, the operating system will add an event to this queue. This event will be called closed. So what we do in our game, we check this queue, and we loop through this queue and check, are there any events? Oh, there is an event. Cool, let me handle that event. According to the event code, every event has a specific code. In this case, the code of my event is close. That will close the window. So I check the event code, and according to the event code, I execute or I do something. So in our case, if someone clicks on the X screen or the X button on the window, operating system will create an event which is called closed. Our game will check for it, and accordingly, it will handle and do whatever it needs to do. In that case, you just close the window. So those are events. And same thing happens with the keyboard. If I click a key on my keyboard, that will register as an event. So the operating system, which is Windows, will add this event that I press the W key, that I press the W key in this queue. And so our game has to go through all these events. Now, when our game managed to execute an event, it will clear that. So it will remove it from the queue, right? So let's say in this case, I pressed A. So I pressed the A key, I am done, I remove the A key, and then now there's only one event, which is W. When I'm done with W, I delete it. Now there are no events in here. So I'm looping through this queue or this list, but there's nothing here, so I don't have to worry about anything. But the important part is our game has to talk with the operating system. It has to check for all the events, if any events has occurred. W, S, A, D. So all these are all keys on your keyboard. Right? So that's what we're doing in this section. We have a while loop. We're saying while window.pull event. Pull event is a function that basically checks for events, for all events. And this check will be saved, right? This is a function called pull event. Whatever event it has will be saved in this variable over here. So SF event is a class, and this is an object out of this class. And so whenever I do while window pull event, when I check for the event, if there's an event, I save it in this variable, and then I check with an if statement. Now, we haven't talked about if statements before. So let's talk about if statements. What are if statements? Well, essentially, an if statement is a check. A check if something is true or false. So for example, I say if age is bigger or equal to 13. So in here, I have an if statement. Right? So I have an if statement here that checks if age is bigger than 13. If age is bigger than 13, then I will execute this code. I'm going to say print happy birthday. However, if my age is less than 13, then I'm not going to execute this code. You can see that the if statement has a scope again. The scope is this curly brace and this curly brace. So any code that is written between those two curly braces belong to the if statement and will only be executed if this condition is true. So hold on. What's the difference between an if statement and a while loop? They look very similar. So with a while loop, you have while, a condition, let's say age is bigger than 13, print happy birthday, right? I'm just gonna do this, right? Happy birthday. So these look very similar. What's the difference? This is a while loop. This is an if statement. There's a condition here. There's also a condition here. If the condition is true, I'm gonna execute this code. If the condition is true, I'm gonna execute this code. What's the difference? Well, with a while loop, it's in the name. It's a loop. So a loop happens more than once. So as long as this condition is true, the loop will happen over and over and over, and it's going to print happy birthday over and over and over and over as long as your age is 13. If your age goes below 13, it will stop printing happy birthday. So that's a while loop. However, with an if statement, it checks if the age is bigger than 13. And if it is, it will only print happy birthday once. So an if statement is only for something that happens only once. So that's what an if statement does. A while loop happens over and over and over. An if statement only checks and happens once. But they both have conditions. So there's a condition here. And they both have these conditions. They both have to be true for the code inside these curly braces to be executed. That's important. Right. So going back to my code here, I have a while loop. I go inside my while loop. I pull for events. I look for events in our list of events or queue of events. And I save the event in this variable, which is event. And then I check. If the event has a type of SF event close, SF is a namespace because it has 2 colons. And it checks if the event is closed. If it is, then I do window.close. So the window object has a function called close. All right, so let's write up this code. If I go here, right, I'm gonna say if, so I'm gonna, first I need to create my event. So event, right? Now event is an object of type event, right? This is my variable, this is my object, and this is the class. So in here, I do a while window.pull event, right? So this is my window, and it's pulling my event, checking for events, and it will save any event that it finds in this variable or this object. Once we find something, or once we find an event, we would like to check the type of this event to act accordingly. So I do event.type equal to SF event closed. And if the event closed, then I do window.close. All right. Now, something you might look at and you might be wondering, why is that happening? Why is there a double equal here? Why not just equal? Well, a double equal means that I want to check for equality. I'm checking if this is equal to this. If I do a single equal, I am basically saying that this is equal to this. So this is assignment. I am assigning, so this is a variable, right? This is my variable. I am assigning my variable a value of SF event closed. In here, I am checking if this has the value closed. So double equal is for checking, single equal is for assignment. To give you another example, if I do int health equal to 100, and I check if health equal to 5. So in here, I am just checking the value of health. I'm asking, is the value of health equal to 5 or not? If I do a single equal, I am saying health is 5. I'm changing the value of health to 5. Even though if it's in an if statement, it doesn't matter. It's going to execute this code and health will become 5, which is not good. We want to check if the health is 5. Right? So double equal is for equality check, single equal is for assignment. So to go over this one more time, I'm creating an object called event. This object has a data type of event. I am looping through the queue of events for my operating system, and I do that from my window. So in window, I pull for all the events, I loop through all the events, and if there's any event, it will be saved in this variable, which I created at the top here. Now inside this loop, I check what's the type of my event. Is the type of my event close? If it is, then I'm going to close my window. With that code written here, if I press play now, and I close my window, now here's the thing, I can now move my window, which is super cool. I can minimize my window, right? I can maximize my window. I can maximize it, right? And I can interact with it. And now I can close it. If I close it, it closes. Now notice if I remove these two lines, right? I'm only pulling for event. I'm only checking for events. And if I run my application now, I can still move my window. I can still minimize my window, right? But if I click on close, nothing happens. Because I'm never checking for that event. I'm never checking if the window close button was pressed, which we do previously. If we press it, then we close the window, right? And that's important. So now I have to save my code and restart it again. And now if I click on the window here, it closes, right? So that's important. All right, so those are events. What's next? Well, the last two lines that I would like to talk about is window clear and window.display. So let's write these lines up first. So I'm going to do window.clear. And clear, if you look at the function here, it returns nothing. Clear returns a void. It's not going to return anything. However, the input here, you can see that it takes a color. What's a color? Well, SFML has a class called color. And this color class has a default color or some default colors that exist. For example, black or white or red or whatever you want. We're going to do red. So essentially here, what we're doing is we're clearing the window. Remember when we talked about double buffering and rendering things on the screen over here? Remember what we said? Before we draw something on the screen, we first have to clear it. We have to remove everything from the screen. That's what we do on this line of code. We clear the window so we can draw the frame, so we can draw our stuff. Next is window.display. What does window.display does? Well, if you hover over it and look at it, it returns nothing. It returns a void, which is nothing, and takes no inputs. So what is display? Remember the back buffer that I talked about? This back buffer? Whenever you call display, you're basically copying the data from the back buffer to the screen. So notice what's happening here now. Let's look at this step by step. When you call clear, I'm clearing my screen. So let's do that. Let's clear our screen. On this line of code, I cleared my entire screen. On display, on this line 19, when I do window.display, what I'm doing is I'm copying the data from the back buffer. Anything that I drew on the back buffer, I'm copying it to the screen now. So now I'm drawing stuff on the screen. All this data, I'm going to draw it on the screen. Right? And that's that line. So by default, SFML allows us or enables back buffering, right? Or double buffering, right? We have a back buffer on our screen. And when we want to display something on the screen, we do window.display. So now if I press play, all I'm going to see is a red window, which is cool. You can see I have a red window. I can close my red window. And if I want, I can make a yellow window by changing the clear color and say yellow, which is super, super cool. Like this, right? Now, this line right now doesn't do much. Like window display, it's kind of useless because we're never drawing anything on the screen, right? But next time, when we draw stuff, we draw it between clear and update. So we drew our drawing here. So we clear the screen, draw stuff on the back buffer, and then copy the stuff from the back buffer to the screen. So if I want to draw a circle, I do it between line 17 and line 19. So a draw circle happens here. If I want to draw a triangle, draw triangle. If I want to draw a character, draw player. I do it here. If I want to draw my enemy, draw enemy. So look at this now. I am clearing the screen to a color. All the pixels on the screen, I'm clearing them to yellow. And then I'm drawing a circle on the back buffer. I'm drawing a triangle on the back buffer. I'm drawing a player on the back buffer, and I'm drawing an enemy on the back buffer. When I'm done drawing stuff on the back buffer, I call window.display to copy stuff from the back buffer to the screen. Right? And so we do that every single frame. So here's the thing. Now I'm going to section off my loop into two sections. This section will be the draw section. Right? All my drawing is going to be between this and this. All my updating is going to be between this and this. Remember when we said we have two functions in our main loop? If I go back to my main loop, we said we have two functions. We have the update function and we have our draw function. The update function, or we're not making it a function right as of yet, we're just starting code. So this is the update section of my main loop or my game loop, and this is the draw section of my game loop. Right? And I section it off like this just to make things a little bit clearer. It's not very good to update stuff between window and clear. Like I could, if I want to, I can do update code over here. For example, I can check for the movement of my player. I can update the animation in here, but it's not good. It's better off to section off my code to a section where it only does update and a section that only does drawing. Don't be messy. Don't mix things up together. Keep update alone, keep draw alone. All right? So let's look at our code a little bit. So if I zoom out a little bit here, let's do a final review. I'm including my SFML graphics header file. I have a main function, which the operating system invokes or enters when you open your application for the first time. In here, I'm creating an object that's called window. This window object has a data type of data type of render window. SF is a namespace. Right? SF is a namespace, render window is a class, window is an object of type render window. Whenever we're creating our window object, we are also calling a constructor. A constructor is a function that is executed whenever you create an object. In this case, my object is a window. So I'm calling a function. This function takes two parameters, or it takes two input. The first parameter, or the first input, is SF window mode. The second input is my game title. SF video mode itself is a class, which takes also two parameters. The first parameter is the width of my window and the height of my window. Once we created our screen, we need to create our main game loop. Our main game loop is created by making a while loop. All of this is the main game loop. A while loop is just a loop that happens over and over and over. It executes code over and over and over as long as this condition is true. In our case, the condition is while window is open. Window is our Window is our object that we created at the top, and this object has a function that's called isOpen. IsOpen is a function that takes no input. However, it does return a boolean, and this boolean is true or false depending on whether the window is open or closed. So while the window is open, we update our code and we render our, we render whatever we need to render, or we draw whatever we need to draw. Every time we go through this loop, we draw a single frame, one frame. So if we need to draw 60 frames per second, this loop has to execute and run 60 times in 1 second. Update, draw, update, draw, update, draw. All right, let's go to the update section. The update section, what we do is we create an object called event. This object has a data type of event. Event is a class created by SFML with a namespace of SF. After we create this object, we have a secondary loop. This second loop, we check and we pull for window events. What are window events? Window events are like clicking on your keyboard, clicking on your mouse, moving your mouse, closing the window, maximizing the window, moving the window, minimizing the window. All of these are different events that happen when you interact with the game window. So in here, we're pulling for all the events from the operating system. We're checking the queue of events. If there's an event, it will be saved inside this event variable. Inside this inner loop, I have an if statement that checks the type of event, because there could be many types. There could be a type that you're moving the window. There's a type that you're closing the window, a type that you're maximizing the window. In this case, I'm checking if the type is equal to the window closed or the event close. So here we're saying if the type of event is closed, which means if we close the window, then I should go ahead and close the window. Window is the object that we created above here, and it has a function that's called closed. This function returns nothing and it takes nothing. And so whenever we click on the close button, we close the window. If I want, I can say this, stdc out, haha, not closing the window, loser. So now, scOut cannot be found because I need to include IOStream. Remember, IOStream is for input and output stuff, so we need it. So now, when we click on close, when we close the window, when we click on that close button, and instead of the game closing the window, I'm gonna print this message that says, hey, hey, haha, not closing the window, loser. Let's try it. If I press play, right? And look at the terminal, right? Gonna close the window. Haha, not closing the window, loser. Look at it again. The window's not closing. Right? And the only way to close this is by closing the terminal. Right? So this function, if I control it a little bit more. This function here, close, basically it's just a function that closes the window. And we execute this when we click on the X button on the window. All right, so this is our event section. What about our draw section? Well, our draw section has a function called clear. The clear function exists inside our window object. The clear function returns nothing. However, it does take one input. That input is a color. Color is a class inside SFML which allows you to define some colors. And there are predefined colors like yellow, green, pink, whatever. Now, one thing you might be confused about. Remember we said SF colon colon, right? And we said whenever you do SF colon colon, or whenever you type something and do colon colon, that's a namespace. But well, here's the thing. I'm also doing colon colon here, and color is not a namespace. Color is a class, and it clearly says here it's a class. How come we're doing colon colon? Well, I'll explain that later. But essentially, SF is our namespace, color is a class, and in our class there is a variable, right? That's called yellow, which we're using here. We'll talk about why we're doing colon colon here, even though this is not a namespace. This is a class. SF is a namespace, color is a class. All right, so in here what we're doing is we're clearing the window color to a yellow color. So all the pixels in the window, we're turning them yellow. Once we're done clearing the entire window, we're copying whatever exists inside the back buffer onto the screen. So whatever on the back buffer that we drew, we copy it to the screen. Right now, we drew absolutely nothing. So this line is completely useless. But later on, when I draw stuff in here, like a circle, that circle, we drew it on the back buffer, and then we're going to copy it to the screen on this line. Now, that is the entire application, and that's how the entire thing works in SFML. There's a lot of information here that I talked about, especially when I mentioned colors. We didn't talk about alpha yet. We didn't talk about what the alpha channel is, right? We talked about pixels. We talked about the back buffer, triple buffering, double buffering, screen tearing. We talked about events and event queues. We talked about vsync and refresh rate of a monitor, the different refresh rates of a monitor. We talked about the game loop and what the game loop does, right? We covered a lot today. So what I want you to do is kind of digest all this information and try to write this code. Copy it for the first time if you want to, that's fine. But the next time, try write it yourself. Try experiment with things and see what happens when you change things up. For now, I'm gonna leave you on this, right? Our application works, which is great. I run it. I have a yellow screen, which is fantastic. Next time, what I'm gonna do is instead of just having a yellow screen, I'm gonna draw something on the screen, like a color or a cube, not a cube, a rectangle, or anything. All right, I'm gonna leave you guys off here. Hope you learned something. Hope this made sense. And again, as always, if you have any questions, you can write it in the comment section below. I'll read it, compile everything into a YouTube video answering all the questions out there. All right, you guys take care. I'll see you later.